Hello class, this is a video tutorial on the integration of higher powers of sine and cosine. So by using these identities of cos squared of x and sine squared of x, we can use this to integrate these functions. Now here's a simple proof to show you that these identities are indeed what they are. So we know that cos of 2x or 2 of nx is cos squared nx minus sine squared nx. From here we get cos 2 cos squared nx minus 1, and rearranging this, moving 1 to the other side, we get this plus 1, and then halving everything. So half times everything gets us this here. And a similar one can be done with sine squared of nx. Now with that simple proof out of the way, let's just show a quick application of this. So for this, we change our integral using the identity. So we actually get half 1 minus cos of 2 times n of x. N right now is going to be 9. So when we multiply it by 2, we get 18x dx. From here, I like to factor out any constant values, like so. And from here, we just integrate as we normally would. So we get half, times x minus 1 on 18 sine of 18x, and multiplying everything by that half on the outside, we get half x minus 1 on 36 sine 18 of x plus c. Hope you can see it's not too difficult, just applying these identities for here. Let's now do it again for this one here. So the integral remains the same, but now we're going to convert just this one here. So just this one on its own becomes half 1 plus cos, well in this case n is going to be that 1 here, so 2 times 1 is just 2x plus 1 dx. For this, I'm going to expand. We get half plus half cos 2x plus 1 dx. Adding the 1, we get the integral from 0 to pi, 3 on 2 plus half cos 2x dx. And we integrate from this point forward. Integrating this, we get 3 on 2x plus 1 on 4 sine 2x from 0 to pi. Substituting pi first, we get 3 pi on 2 plus 1/4 of sine of 2 pi is going to be 0 minus 3 on 2 times 0 plus 1/4 sine of 0 is going to be 0 as well. So in actual fact, all of this is just 0. So we get, well, timesing by 0 here, that's also 0. All of this is 0, which leaves us with 3 pi on 2. Now the main focus here is, I hope you can see that we can just simply use these identities to substitute and make our integral possible, because we currently do not have an integral for this one here. Likewise, for cos squared of x, we simply use the identity and apply all the regular integration rules as usual. So I hope to see you in the next video, and best of luck.